examples, it'll be fine. Okay? So take a look at the top. We did one kind of like this maybe the other day, I think, on the back of a notes. So you have a chart. What's in the chart? You have F, F prime, F double prime. How do I find X coordinates for local mins and maxes? What do I need to find? It's very critical that you remember. Okay, critical numbers, yeah? Okay, which is the same as the first derivative. Now, what do I need the first derivative to be? Equal to.
0
or undefined. Very good. So look in the F prime row of the chart. Where is F prime equal to 0 or undefined?
1 and 2.
Okay, so it's undefined at 0. It's 0 at 1. It's undefined at 2. So my critical numbers are 0, 1, and 2. So let's set up a number line here. 0, 1, 2, 3. Now, notice that on my number line, why am I not putting arrows? Look right here. What type of interval are we looking at? Closed interval. So we're not going all the way to infinity. We're cutting the interval off on the sides. Okay, then from there, from 0 to 1, what's the sign of F prime between them? Negative. Other side?
Negative.
Then? So negative, negative, positive. If those are the signs of F prime, what does that tell me that F is doing? Use increasing and decreasing are your words. Decreasing, decreasing, increasing. Do I have a local min or max? Where? Min at 2. Very good. So I would say I have a local min. Say it again. Because it goes from down to up. Where it changes. Okay, local min at 2, then notice that most of the time it'll say justify, so I'm going to go ahead and do it anyway, because F prime changes negative to positive. Negative to positive. Now, if it doesn't say justify, you could just put local min at 2 and that would be fine. Also, can I point out again, some people have asked me, local, relative, same. Same exact same thing, doesn't make a difference. But they will use both. Okay, next question. State the x coordinate where f has an absolute maximum. Okay, an absolute maximum and minimum. Okay, that means that I need to do a candidates table. What goes in a candidates table? What types of things? Okay, x values of critical numbers and endpoints. So my endpoints, if I'm going 0 to 3, need to go in my table. And then also my critical numbers, which were what? Okay, 2 and 1. Okay, now when I plug into a candidates table, what am I plugging those x's into? F of x. I don't have an equation, but I have a chart. So at 0, what's f of x? Oh, look at f. 1. At 1, what is it? 0. Okay, then next one it's 2, negative 1. And then at 3, all that it tells me is that it's negative. So I'm going to put negative question mark. Okay, because we don't have f of 3. Okay, now 1, 0, negative 1, and then some negative number, we don't know what it is. Which of those is obviously the biggest? 1. So we know the absolute max is 1. It occurs at x equals 0. Okay, but for the min, we're going to have to do a little bit of thinking. Okay, so negative 2, negative 1 is negative, and then at 3 it's negative. What happens between 2 and 3? It increases. So I want you to think about which one is going to be smaller, negative 1 or the unknown negative, if between 2 and 3 my graph increased. Negative 1 is smaller. One more time if you didn't catch that. I know negative 1 is smaller than my unknown negative because between 2 and 3 my graph went uphill. So no matter what this negative number is, I know it's bigger than negative 1 because it increased to that value. So I'm going to put my absolute min is negative 1 at x equals 2 because on 2 to 3, f increased. So f of 2 is less than f of 3. And that's the only number I didn't really have a value for, was we didn't know what f of 3 is. So even though I don't know what it is, I know that f of 1 is small, or f of 2 is smaller. Does that make sense? Okay. Letter C, and maybe put a star on that. That one was a little bit tricky, okay, but the other one should have been easy. You just set up the chart. Letter C, I want to know where my graph is concave up. What part of the table should I be looking at? Double prime. What sign do I want? Concave up, I want positive. Let's find our PPOIs first. Okay, where do I have a PPOI? Undefined or 0? 1, 0. Anywhere else? 2. The exact same 3 PPOIs. So, PPOI, double prime, 0 or undefined. At 0, 1, 2. Set up your number line. Remember, no arrows on the end because we're looking at a closed interval. So 0, 1, 2, 3, then stop. No outside of that. From 0 to 1, what is the sign of f double prime? Positive or negative? Okay, it's positive, then what? Then, so it's plus, minus, minus. And we're pulling those from the f double prime part of the chart if you want to label it here. Now, what does that tell me about concavity? It's concave. Up, down, down. Up, down, down. So, I want to know where it's concave up. What would I put? 0 to 1. CCU on 0 to 1. If it said justify because f double prime of x greater than 0. If it was concave down, instead of a greater than 0, I would have put a less than 0, but it would have been basically the same. Okay, next one. I want inflection points. Where is my inflection point? Is it 1 and 2? Only 1, because what happens at 1? Concavity changes. Remember, if the concavity doesn't change, it's not a point of inflection. So 2 does not count. So I'm going to put POI at x equals 1 because concavity changes. Since f double prime of x changes sign. Okay, hey. I have a point of inflection at x equals 1 because concavity changes since f double prime, you can sit at my desk, changes sign. Make sense? Now, if you left this part out, that would probably be fine. Okay, I would put it just to be a little extra, but I think you'd be okay if you didn't. Okay, point of inflection. Also, sometimes it's called an inflection point. Is a possible point of inflection. And remember, what's the difference between a possible and an actual point of inflection? There has to be a change for it to be one of these. So this is like a maybe, and that's like a yes, there was a sign change. Okay, last thing, part E. Okay, set up a graph, 1, 2, 3. It says sketch a graph of the function with all of the characteristics of f. Okay, first thing we're going to do is draw in any y values that are given in the chart. So look at the chart. What was f of 0 in the chart?
1.
So 0, 1, there's a point. Okay, now move over. At 1, what was the y value? 0. Or actually, look where else these are. They're also in my candidates table, right? Okay, then 2, negative 1, that should be my next point. 2, we'll say negative 1 is maybe here. Then my last point, 3, I don't know exactly what to put, but I'm just going to write negative for right now. So I have 0, 1, 1, 0, 2, negative 1, and then a negative y value that we don't know. I'll put negative y value. Okay, all that you have to do to sketch the graph correctly is to look at if it's increasing or decreasing, and if it's doing it concave up or concave down. So my first little chunk, I'm going to look at both my first and second derivative tests. What is my graph doing from 0 to 1? Increasing or decreasing? How is it decreasing? Concave up. Draw that connecting the first two dots. Decreasing, concave up. Your graph should look like that. Okay, not so bad. So decreasing, concave up. Okay, next section. From 1 to 2, we'll do this one in purple. What's my graph doing? But it's concave down. So I'll draw a graph that's decreasing, concave down. Should look like that. Okay, then last little chunk of the graph, we need it to be what? Increasing, concave down. Now, it needs to stay negative. So when you draw it, can I draw it up like this? No, it has to stay below. So maybe like that.
Would it flatten it out or would it still curve?
Oh, you could do it either way. You could make it kind of just maybe go up and never flatten out all the way.
So it would be like an asymptote. Like if it is
Yeah, you don't know if it's an asymptote or not, and that's why too it just says to sketch it with those characteristics. So if your graph, if you made it curve a little faster or whatever, it's just the shape that they're grading. Make sense? Okay, now let's double check all of the crap that we said with the graph to make sure that it's all right. Okay, statement number 1. We said we have a local min at 2. True or false? 2. True. I have a local min at 2. Also, we said that there's a flat spot at 1.
Yeah.
At 1, is there a flat spot?
Yeah.
Okay, then we said that there's concave up 0 to 1. Is it concave up? Okay, and then, oh, the other thing I wanted to point out, look here. What did we say f prime is at 2? What happens at 2 in your graph that you know there's no f prime there? Cusp. Okay, so here I'm going to put f prime of 2 undefined because cusp. Make sense? So after you have filled out all that stuff, you should be able to kind of sort of check and see if your graph is right. Okay, next thing I want you to do, in your packet, it was copied kind of out of order. You're going to turn to this page right here. The big graph's at the back. You're on the back of the second to last page. Okay, so this is where you might need to think a little bit outside of the box. Okay, first thing I want you to do is label this graph as a graph of f prime of x. So this is not a graph of f, this is a graph of f prime. We do not have the graph of f. So I'm going to put don't know graph of f of x. It's missing. We don't know what it is, but we have the graph of f prime instead. We can still answer questions about f if we have a graph of f prime. So, first thing we're going to do is find when f is increasing and decreasing, where I have relative mins and maxes. But we're going to have to do it based on the definition. So, how do you find critical numbers to do a first derivative test? You look for where f prime is what? 0 or undefined. So I'm going to put critical numbers are when f prime of x is 0 or undefined. Okay, now look at your graph. Does it ever equal 0, my graph of f prime? How many times? 3. Look at your x-intercepts. F prime equals 0 at -3, at 0, and at 3. So if I were to make like a little baby, we'll say first derivative test here, -3 0, and 3 are all going to go on it. Now, before negative 3, what was the sign of f prime? Was it positive or negative before negative 3? Negative. How do you know that? Because it's below. It's under the x-axis, right? Those are all negative. Okay, what was f prime between negative 3 and 0? All of these values are positive. So I would put a positive. Then from 0 to 3 on this little section of the graph, what's f prime? Then positive. What does that tell me? That f, which I don't have a picture of, what would f have been doing? Decreasing, decreasing, increasing. So when I list my intervals, my graph is increasing from negative 3 to 0, which is here, and then from 3 till infinity. So negative 3, 0, union 3 to infinity. Because f prime of x greater than 0. And then I'm going to put in parentheses behind that, it was above x-axis. So because f prime was above the x-axis, I know it must have been positive there. Now, for the opposite of that, I want decreasing. Where is my graph below the x-axis? Or look at your first derivative test. Okay, very good. From negative infinity to negative 3. And then 0 to 3. Okay, then I would put because. Perfect. And then if you want to put behind that in parentheses, it's below the x-axis. Make sense? Okay, now, given that information, look back at your little mini first derivative test. Okay, where do I have a local minimum? There should be 2 places. You can look here. Look at our little baby first derivative test. Negative 3 and 3. Okay, what happens at 0? It's a max. Very good. So, I have mins at negative 3 and at 3. So I'm just going to put plus or minus 3 because how did f prime change sign? Backwards. Negative to positive. Now, question. On my graph, what if I hadn't made a number line? Okay, could I still tell that it goes from negative to positive?
Yes.
And this one, negative to positive? So I'm not going to draw that every time. I just did it on this one to make it a little more obvious. So this is a negative positive switch. This is a negative positive switch. Okay, where do I have a maximum then?
0.
Plus to minus. So at 0. Because f prime changes positive to negative. Okay, concave up. Let's talk about concavity. This is f prime. So I can't just look for where it's up like a cup. Okay, if I want concavity, that's f double prime. What is the relationship between f double prime and f prime? What is f double prime? The derivative. What's derivative in a graph? Slope. So f double prime is the slope of f prime's graph. F double prime is the slope of f prime's graph. So, look at your graph. I'm going to do this one for you just so it doesn't take forever. I'm not going to draw one of these out. Okay, but remember, f double prime is the slope. How does my slope start off on the graph? Positive or negative? Positive. Positive all the way until when? Negative 2. Put a big X there at negative 210. Okay, then, from that point until when is my graph a negative slope? All the way until positive 2. Then put another X. Okay, then after that value, what happens to my slope? It turns positive. That means that those places that you put X's, those are your POIs. So your mins and maxes are the x-intercept for f prime, and then your curves or bends are going to be where your points of inflection are, if it's a graph of
And that's
f.
how it's going to be for all.
If it's a graph of f prime, yes. Okay? So, think about, if I want to be concave up, what kind of slope does this need? Positive or negative?
Positive.
So I'd be going negative infinity to negative 2. And where else did I have a positive one? 2 to infinity. Good. Now, even though it's a little bit weird the first time we do it, this is going to eventually be really easy. And the last 15 years, one of the FRQs has been one just like this. So these should be your easy points that even if this is not your strong suit, this should be by the end of the year. Okay, concave down. Where's my graph have a negative slope? Negative 2 to positive 2. Now, let's work on the because. I need to say that f double prime of x is less than 0. Okay, however, on the AP test, they're not going to accept this because you don't know f double prime. They didn't give you the equation and they didn't give you the graph. So what you would have to do instead of that is say f double prime, the slope of f prime is less than 0. And what you have to do is connect it to what they gave you. So you would say f double prime, which is the slope of the graph you gave me, is less than 0. And even though it's kind of annoying, you just do it every time and it'll be easy. Okay, second one, I would do f double, and actually this is backwards. What should it be if it was concave up? Greater than. Okay, then for the second one, I'd put f double prime, the slope of f prime, less than 0. Okay? Last one, points of inflection, we said we're at negative 2 and 2. Because f double prime, the slope of f prime changes sign. And then somebody in the other class was like, well, wait, that's not really a point of inflection, it's still concave down. This isn't the graph you're answering the questions about. What is this a graph of? F prime. What are we answering questions about? Regular f. We don't have a picture of that. Now, given that we just did it, could I sketch a picture of this? Sure. We're not going to right now, but you could. Okay? All right, go down to the next one. We'll do one more together, then you get your candy. You can do it. Look at Ebenezer up here, wide awake. Okay. Put dots on the critical numbers. How many critical numbers should you be putting dots on? 4. 1, 2, 3, 4. Okay, for the first section of the graph, is it above or below?
Is this graph for y prime?
This is f prime, yep.
Y prime.
Yep. So it's above, that means it's positive. Then it passes through the x-axis and turns negative. Then it stays negative until 2, then it turns to a positive. Then it stays positive until 4, then it turns negative. Then it stays negative until 8, then it turns positive. So on which intervals will the graph of f that I do not have a picture of, where will it be positive? 3 places. Okay, all the way till negative 4, then 2 to 4, then 8 to infinity. Good. So, negative infinity to negative 4, union, 2 to 4, union, 8 to infinity. Because f prime greater than 0. And in your mind, you know that that means above. Now, if it's increasing on those intervals, it's decreasing on the ones we didn't shade, right? So what would those two intervals be? Okay, negative 4 to 2 and 4 to 8. Because f prime is less than 0 or below the x-axis. Okay, now, I want you on your paper, don't say it out loud, mark which ones are mins, which ones are maxes. Remember, maxes are changing which direction? Plus to minus, and then mins are changing which way?
Negative to positive.
Negative to positive. So mark them on the x-axis. -4, what is it? Max. 2, what is it? Min. 4, what is it? Max. 8, what is it? Min. Okay, then I would say I have mins at 2 and 8 because f prime changes negative to positive. Then I have maxes, we said, at -4 and 4 because f prime changes plus to minus. Now, someone in the other class was like, why can you put f prime here and not f prime of x? Those are the same. It doesn't matter. You can call it f prime of x here. You can call it f prime here. It's just a shorthand. They're both fine. Okay, last 3 things. Concave up and down. What am I looking for in the graph?
Slope.
The slope. F double prime is the slope of f prime. So when I'm looking for a positive or a negative slope. So on the graph, I want you to put x's everywhere that the slope changes sign. Put an x everywhere that the slope changes direction. Can go from plus to minus or minus to plus, either way. How many x's are you putting? 3. 1 here, 1 here, 1 here. Okay, where is my graph concave up? I'm looking for uphill sections. -1 till when?
-3.
Till 3? Where else is it uphill?
6.
The 6 to infinity. Very good. So I'd be looking for -1 to 3, union, 6 to infinity. Because f double prime, the slope of f prime, greater than 0. My slope is positive, and that tells me that the slope of f prime is f double prime, which tells me concavity. Where will it be concave down? Negative infinity to -1 and 3 to 6. Very good. Negative infinity to -1, union 3 till 6. Okay, because blah blah blah, f double prime, slope of f prime, less than 0. Okay, one more left. Points of inflection, where are they? -1, 3, 6. Because f double prime, slope of f prime, changes sign. So as long as you know how to find them with equations, you're just thinking about what the definitions are and then looking at the graph. Okay? Alright, I'm going to bring you a candy. I want you to do the 2 on the next page. You still have, how many minutes? 11 minutes for 2 easy graphs.
Too easy.
Too easy. Okay? So turn the page, you're doing the next 2. Now, I'll give you a hint. On the next 2 graphs, some of them you're not going to have everything. You can just put none. So next 2 graphs. You can turn it off. Jeez, Jenny. You dying over there? Okay, you can do it.
Miss Mary's the restroom?
Yes, you may. 2 questions. Work with a friend. Candy to warm you.
I knew there was a close.
You know, there are kids starting around the world. Begging for an education and theory.
I sucks because I dropped my pen first of all.
I dropped my pen and I have to move to pick it up.
That's why my life sucks. This and that.
Meanwhile, kids in Africa are hiking for a cup of water.
That sucks for them.
Where you?
Oh my god.
I'll be born in America. That's okay.
If I'm having a bad day.
Okay, you're doing the next two graphs. Right, King? One? Wing, you want a candy?
Definitely show up when we give it a minute.
Candy?
Next year we'll put the-
Why do you all not like Tootsie
Also
Rolls?
kind of this.
These always end up on leftovers. I just hate those.
Before we have them shoot puppy, you know?
No, I don't like
Yeah, I don't know.
the irony of that question. Okay, have a candy. Yum. Now do your work.
Oh,
Do it.
tell me why. I was like,
You can do it. Where are the critical numbers on the x-axis?
2 and 4.
No.
No?
I thought you were taking away.
Isn't it not one?
Okay, put dots on your x-axis.
See, I was looking at these examples. See, I know how to do this. But then when you helped me, because like you would say some stuff, and then okay.
Okay, so put dots on the x-axis.
Yeah.
Okay, and then put your pluses and minuses. When it's above, it's positive. When it's below, it's negative. Okay, so then if that changes from negative to positive, is it a min or a max? Okay, and then what about the next one?
What happened to
Max.
physics?
Okay, now if you want it increasing or decreasing, you want it to be above. You think about it, you think about it.
No, you're right.
Yep. Now, where is it increasing then?
Right.
Well, no, remember, you want it to be above for increasing.
Oh, so 2.
2 till,
It's like,
so you're giving like the intervals, does that make sense?
Yeah.
it's like all of it.
And then decreasing.
For wherever it's negative, so where is it below the x-axis?
Oh, okay.
Andy?
I can go.
Yes.
What's this?
Yeah.
I'm trying to get into the
Okay, put dots on the x-axis. Y'all remember, this is the graph of f prime, so you can't just look at it and tell me that there's a max at the cusp. Okay, that would not be correct. Okay, so look at it. Where are my critical numbers? What are they? 2 and 4. Hopefully we at least got that. Okay, then you put negatives and positives where the graph is above and below. So at 2, where is it before that? Negative then. Okay, at 4 what happens? Above to below. So what type is 2? Min or max? Min. Okay, then it changes at 4, which direction? Max. So I'm going to skip to these two since we did it. I have a min at x equals 2 because f prime changes negative to positive. X equals 4, I have a max because f prime changes positive to negative. Okay, now let's do increasing, decreasing. My graph of f that I do not have a picture of will be increasing when this graph f prime is positive. Where is it positive? 2 to 4. It was all pluses there, so 2 to 4 my graph would have been increasing even though I don't know what it looks like. Because f prime was greater than 0 or above. Where will my graph I don't have a picture of be less than 0 or, sorry, decreasing?
2 and negative 4 to 2.
Okay, good. So you could do negative infinity to 2 and then 4 to infinity. Okay? Then f prime of x less than 0. Okay, now when you get to concavity, that's where it's a little tricky. You're looking at the what of the graph? The slope. Put in x anywhere that the slope changes direction. How many x's should you be putting down? 1. Where should it be? At 3. Before 3, what's the slope? Positive. Is that concave up or concave down then for the original graph? Up. So negative infinity till 3. Because f double prime, the slope of f prime, is greater than 0. Oh, I put of prime.
Oh, then concave down would be greater than negative.
Yep. 3 to infinity would be concave down, because f double prime, the slope of f prime is less than 0.
Point of inflection.
Okay, point of inflection, did my concavity change?
3.
At 3. And you don't have to put the because, you can see it on the other 2 examples. Okay, one more left. I'll give you another maybe like minute to give it a shot if you didn't get to it. So dots on the critical numbers, then label them a min, max, or neither. Yep. How many critical numbers do I have? 2, yeah. So I have 1 at negative 3, I have 1 at 3. What's the sign before negative 3, above or below? Above is positive. Above is positive. Is that a min, max, or neither? That's a neither. Okay, then I look at 3. It's positive, then positive. What's that? Neither. So when I look at my graph for increasing intervals, where is it increasing? Negative infinity to negative 3. Negative 3 to 3. 3 to infinity. Do I have to break that up? No. All real numbers. Or you could put negative infinity to infinity. Now, here's the only thing you have to be careful about. If I put this, that's wrong. What do I need to adjust if I'm going to include the zeros? My greater than needs to be greater than or equal to. If I don't want to break it up, I just have to put a little equal to on there and then it's fine. So it's either positive or it's touching. And then that's fine. Now, where is it decreasing? When is it below? None. So I'm going to put NA. Okay? And then for my because, I'll put F prime, never negative. Okay? It doesn't ever go below the x-axis. Then where are my mins and maxes? None. Because why? F prime, it never changes sign. That's right. And if it doesn't change sign, then I can't have mins or maxes. Now, can I still have concavity changes?
Yeah.
Yes, because concavity is the slope. Does the slope change sign?
Yeah.
How many times? 3. 1, 2, 3. So I'm going to put for my point of inflection, I have points of inflection at negative 3, 0, and 3. Because F double prime, slope of F prime changes sign. Okay, and then just since the bell's about to ring, I'm only going to do one of those. Let's do concave up. Concave up, I'm looking for a positive slope. Where does it happen? Negative 3 till 0, I have a positive slope, and then 3 to infinity. So negative 3 to 0. And then 3 to infinity. No, we have concaves down. This one would be down, and then that one would be down. But the bell's just about to ring. Okay, got it? So the only homework due tomorrow is homework 2. Homework 3 is not due till next week. You can maybe start it, but it's not going to be due till next Friday. Good job. You can do it. Now meet your neighbors.